3 island perimeter in JavaScript using an optimized brute force with early termination. You're given a row by call grid representing a map where grid ij equals 1 represents land and grid ij equals 0 represents water. So a row by call grid, it's row major. So this is a row, that's a row, that's a row, and that's a row. And it corresponds to this nice picture they added here. Row 0, row 1, row 2, row 3. Row 0 has water, land, water, water. Okay, grid cells are connected horizontally, vertically, not diagonally. The grid is completely surrounded by water. There's exactly one island. Exactly one island. That's key. This is kind of, I don't know why they even say that. It doesn't need to be said. The island doesn't have lakes, meaning the water isn't connected to the water inside isn't connected to the water around the island. That's garbage wording. There is no water inside. So that's pointless to say. It's confusing. The island doesn't have lakes, meaning there isn't any water inside the island. That's the correct way to say it. One cell is a square with side length 1. So a lot of times LeetCode will throw in just garbage nonsense like this, and you have to figure out, is that important? And usually it is, but in this case, it's just garbage. Okay, so what we need to do is we need to find the perimeter. Here's our grid. The output's supposed to be 16. We go through the rows, and we go through each cell of each row, representing the columns. So row 0, column 0 is water. Row 0, column 1 is land. And so we can add 3 for that. We go to our next row. Row 0, column 0 is land. We add 3. This is land. We add 0 because there's no water or nothing. It's touching land on all sides. And then row 1, column 2 is land, and we have add 3 on there for the water that it touches. So now we're at 3, 6, 9. We go to the next row, 10, 11, 12, 13, 14, 15, 16. This is solved using a loop and a nested loop and early termination. We start out, we have a perimeter, that's going to be our total. We're going to loop through the rows. We get the row. We create a row total. I'll explain later why. We then loop through the columns, the cells. That's what C represents, the cells, cell counter. And if the cell is water, we continue. So we're not going to count anything as a perimeter. If it's water, we're only going to look if it's land. So now we've got land because we didn't continue. So we're going to continue on through this code here. Left edge, top edge, right edge, and bottom edge. These are all going to be Booleans using some JavaScript operators to get the value quickly. The Booleans are then converted back into numbers where we add the Booleans together. True is converted to 1, and 0 is converted to false. So in this case, we would have true, 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 and false, and that would result in 3. The new total, the row total, sorry, and then we're finished with this inner loop. We finish with this inner loop. Once we finish with this inner loop, we check to see if we have a row total. So that's added to the row total, and then we're going to add that to our perimeter. But before we do that, we have to check out to see if we have exited the island. And the way to know that we've exited the island means we have already encountered land, and the current row that we're on has no land. And that's shown in this example down here. We have a row with land, 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 land. Now we have a row with no land. Once we've encountered a row with no land, we are off the island, the number of which there is exactly 1. So exactly 1 island, and we're off it. So in that case, we would break out of the outer loop. This is after the inner loop. And if we're off the island, we break the outer loop because we haven't gotten any more land. Otherwise, we have gotten more land, and we can add that to our perimeter. And then we return the perimeter. And this actually gets pretty good performance. So I've gotten a number of submissions, and you can go ahead and try and run this code yourself. Again, the benefit to using the brute force is if we use a breadth first search, we have to make sure that we don't iterate through the rows twice when we're counting them up. And to do that generally means we have to modify the grid, which is what all of the other solutions in here will do if you go and look through them. You can see, for example, here where we have to. This one creates a set, which is actually quite nice. So instead of modifying the grid, it keeps track of them in a set, which is actually quite nice. Yeah. But this uses brute force, and like I said, gets great performance, and I think it's very readable in comparison to some of the others.